We'll get started in a few moments. Thanks for joining the Maryland Tech Council's presentation of 5G and emergency technologies. We'll give people a few minutes to get antiquated, and then we'll get started. Well, good morning, everyone, and thank you for joining the Maryland Tech Council's presentation on 5G and emergency technologies. I'm Michael Foss from Vision Technologies. We're a Maryland-based technology integrator. I oversee the mobility business unit with Vision that encompasses cellular and public safety DAS, as well as networking and Wi-Fi. In recent years, has Vision rolled out our IoT and cybersecurity initiatives into my business unit as well, bringing a full circle of IP convergence to our customers under Vision's capabilities. Our advances are being driven by emerging technologies in networking and 5G. I started my communications career in the mid-'80s, installing and commissioning some of the very first cellular systems across the country. And I've been amazed at the demand and growth of the industry. So where's it going? What are some of the advantages of emerging technologies? And what impacts will 5G have on these emerging technologies? We're joined today by our panelists from AT&T, Crown Castle, and Corning, leaders in infrastructure and 5G technology. So let's meet the panelists. Let's start with LaTara Harris from AT&T.
Good morning, Michael, and thanks so much for that introduction. I know that several of you, I'm getting text messages from my friends that are already in the event. So thanks so much for having us. We're just really excited at AT&T to be a part of this incredible conversation, especially at a time such as this. If we haven't learned anything about this year, it is about the importance of connectivity and about being connected. So I'm LaTara Harris. I'm responsible for government affairs and external legislative affairs for AT&T in the Mid-Atlantic. Pleased to be with you and absolutely look forward to the discussion ahead. Thanks so much.
Great, thank you, LaTara. Let's meet Bill Cune from Corning.
Hi, Bill Cune from Corning, and I am the VP of Network Architecture in our Corning Optical Communications business. You guys probably know Corning, mostly know Corning from cookware way back in the day, but maybe you don't know Corning from the fact that we're a 170-year-old company. We've been at the forefront of innovation for all of that time. We create life-changing technology and help enable the things that we know and love today. That goes all the way back to the light bulb, with Thomas Edison inventing the filament. We invented the bulb to go around it and the manufacturing process for it. But you go through time, we've developed at Corning multiple businesses around that with display technology. So your phone that you use, your televisions, the glass that on those devices are Corning glass. So it's an important part of this communication revolution. We also have an environmental technology. We invented the catalytic converter. Most people don't know that. We partnered with Ford when the Clean Act was passed to create that technology. As a new problem that had to be solved, Corning stepped up and solved it. Similarly with specialty glass, every spacecraft that has been deployed has had a Corning glass window on it. Very, very special glass that can't expand or contract when the temperature changes. So a lot of interesting things that Corning does, but maybe our most important, well, let me also add in, life science is another one. You guys all probably use Corning or Pyrex beakers along the way in your lab classes and all of that. But with this COVID, you guys may have seen the announcement, but we have a Valor Glass vial, drug vial, that Corning has created. And so many of the vaccinations you'll be getting are likely coming out of a Corning vial. So a lot of interesting things that we do, but probably the most important one was back in 1970, the invention of low-loss fiber optic cable. And we've been the leader in fiber optics ever since then. And I'm with our optical communications business, where we make outdoor and indoor optical communication solutions. Obviously, the fiber, the cables, the hardware to terminate that. And AT&T is a huge customer of ours. Crown Castle is a huge customer partner of ours. And so I'm pleased to be speaking in this panel with them because it takes all of us to make this communication revolution happen. So I always like to joke that Al Gore may have invented the internet, but Corning made it possible with the invention of low-loss fiber optic cable, and the other folks in this panel make it real and make it happen. And 5G is just the next add-on to that. So I'm excited to be talking to you guys about this 5G and emerging technologies, and I will leave it at that.
Thank you, Bill. And finally, let's meet Murat Erkam from Crown Castle.
Thank you, Michael, and good morning to everyone, along with my fellow panelists. My name is Murat Erkam. I'm a member of the Technology Strategy Group at Crown Castle, which is part of the corporate strategy and development team that reports to the executive team. And our goal is to find ways to leverage the Crown Castle assets so that we can serve our customers better and we can be following the advancements in the industry and in the technology world very closely to be able to do that. For about 25 years since its formation, Crown Castle has worked around the country to build and maintain communications infrastructure, shared communications infrastructure. And we do that by providing a comprehensive portfolio of towers, small cells, and fiber that work together. And then has made Crown Castle one of the largest provider of shared communications across the United States. But as Bill mentioned, we don't do it by ourselves. We partner with the wireless carriers like AT&T and technology providers like Cune, along with the businesses, the governments, the communities, to make sure that essential access to essential data, technology, and wireless services is enabled. Just as an FYI, in the state of Maryland, our network includes almost 500 towers, 400 to 500 plus small cell locations, and 1,000 route miles of fiber optic cable installed, covering about 60% of the residents of the state.
Wow, that's interesting. Thank you, Murat. I appreciate that. So I wanted to get started with some questions, but I wanted to remind our audience, if you have questions, please click on the Q&A, should be at the bottom of your screen, and ask questions. We'll try to get to those questions. If it's something that we plan on covering or something that's not answered, we'll try to get back to you in a timely fashion. So let's get started with you, Murat. As we consume more data, the need for wireless infrastructure also increases. So what infrastructure is needed to deliver 5G? You mentioned small cells and macro towers that Crown Castle has. What is everything that's needed to deliver 5G?
Well, very good question and an interesting setup because I've been in the wireless business almost all of my career, but and we use wireless probably today on every instance of our lives. Teenagers have it, probably are thinking that it should be embedded in their hands or in their arms or in their hips. But we do carry our phones with us. And we don't see, we take it for granted, almost like TV service used to be. You turn it on and it works, right? I don't know how it works, but it works. Ultimately, though, for the wireless signal to reach our handsets, it'll have to come through an asset that is either a tower or a street light on the street that has an antenna, and that's fed by what we call a base station, and also has connectivity, electrical power at that site, and connectivity to a centralized location that feeds the content or the information to that base station. And 5G is no different. It's ultimately, you need the similar infrastructure. You need the land to be able to put your vertical assets. You need to be able to put the passive elements to transmit the signal. You need to be able to put the source that will provide the signal. You need to be able to provide the electrical power to turn the source on. And last but not least, you need to be able to connect that base station back to a centralized location, which has its own equipment and backhaul and power and access to content. And a lot of companies or providers has to come together with this. Crown Castle focuses on providing the assets. AT&T as a service provider is responsible for serving the customers, capturing the content, creating plans to be able to make everyone's access to this network work, optimizing and enhancing the network. Corning is needed because, as Bill mentioned, without glass, nothing happens. You need that glass to be able to lay that fiber optic cable. You need to be able to find electronics around that glass to be able to leverage that asset. And then, you know, there are other things that would happen in a in-building environment or an outdoor environment, and other solutions are provided by not only just the providers, panelists here, but other companies in the ecosystem. So 5G doesn't change that. 5G is an enhancement of the wireless technology that's going to enable us new use cases, better service, but ultimately all the things that make wireless work will have to be there to make 5G work as well.
Right. And I know when I got into the industry, you know, cell towers were, you know, sparse 30, 40 miles apart sometimes, much taller towers. And, you know, as we've evolved into 3G and then 4G LTE, it's become more dense. There's more towers. So it sounds like 5G is a lot more dense than previous technologies. You need more of these small cells in order to deliver that.
That is correct.
So
You basically need more locations to be able to serve the
right.
users of the network. And it doesn't mean 5G would not work in the old configuration too, but then you would not take the benefit of the new low latency or high bandwidth features of 5G. And that's why you need to be closer to the users, and you need more of these sites to be able to create almost like a mesh network to provide the service.
So that's a huge transformation. So LaTara, are there any areas in particular that will be transformed by 5G?
Absolutely, Michael. So, you know, I think Murat did a very good job of helping us kind of understand the infrastructure, right? But let me talk to you a little bit about exactly sort of what is happening with the signal as it's going through. It really is a combination of lower latency, massive connectivity, and faster speeds. And those three things combined will create opportunities for us to transform our retail, make autonomous vehicles a reality. We've been talking about the Jetsons for way too long. So it's going to make those a reality, make it possible to build smart factories and revolutionize healthcare. So let me break that down for you a little bit. Lower latency. Think of that as kind of like the moment that you hit the enter key and until you get the response. You look at it in the dictionary, it's a delay before a transfer begins following an instruction for it to transfer. So how quickly that happens, right? So that's what the latency does. It helps to improve that piece of it. Massive connectivity. I'm sitting at my home desk. I've got 3, 4 phones, 5, 6, you know, it helps us to connect far more devices. I will say this, that none of us could have ever imagined, maybe Bill though, because I mean, if you took cookware and did what you did with, you all probably can imagine, but it was difficult to imagine how and how much of the technology that we're using today. No one would have guessed that our young people are using it the way that they're using it. I'm thinking about myself personally. I'm going through a move right now. And my children said to me, Mom, there's no need for you to get a cable box in our room. There's no need for you to do X, Y, Z, because they stream and do everything from their phones. I remember at a time when having a phone in your telephone in your bedroom was a big deal. For them, it's not. You know, they actually want to be able to stream off of their devices. So it gives you an opportunity to have that massive connectivity. And then faster, yeah.
Yeah, that's a great point, you know, and, you know, there's certain areas that are already being served by 5G. But Bill, you know, how will 5G evolve in the complex spaces of high traffic areas, high traffic venues, and difficult to cover buildings or suburban areas?
Well, I think it follows on from what both Murat and LaTara said. You know, when you think about the evolution of 5G, first I think about the evolution to get to 5G, the evolution from 1G to 2G to 3G to 4G. You know, those were all about, well, 1G, 2G was getting to digital, but from 2G to 4G was really about making it faster, you know, making it more, you know, faster and better data rates. 5G is that, plus these other things that were talked about, where the massive connectivity is huge and the ultra low latency is huge. And so this evolution is really, it really is different, and it really is going to enable a lot more than just, you know, higher def cat videos. It's going to be a real transformation in the things that are connected and what we can enable in these buildings and these spaces and venues and suburban areas. And so what I'd say is, the things that happen as we've gone through that evolution, as you stated, towers went from covering 26 miles down to covering a few miles, now down to covering perhaps a half mile. And as the data rates go up, that gets even harder to do. And so you're not penetrating into the buildings. You're not getting the capacity you need inside the building, even if you do penetrate. And so what we've seen happen in these high traffic venues and difficult to cover buildings is that 10 years ago, we were doing a 3G deployment inside of a 100,000 person stadium with maybe 2 or 3 sectors of cell site capacity, and not expecting people to use their phones very much. We are now doing 4G deployments in these same stadiums with 200 cell sites worth of capacity, and down to just a handful of antennas, maybe 10 or 12 antennas, very focused to the capacity on a particular section of the seating for one of those cell sites. And now with 5G, that evolution will happen is that we'll deploy 5G. The carriers will deploy 5G at those same frequencies. They'll layer 5G and 4G on. That's one thing to point out that I think people need to understand. 4G is not going away right away, and 5G doesn't come right away. As with all these other evolutions, there's an overlap, quite a bit of overlap. And today, and for a few years, 5G is not standalone. It still works with 4G, needs 4G to help it make the connection and provide that great experience. And 5G will be deployed at these existing frequency bands that the carriers have, but they're also buying and spending billions of dollars on new spectrum. And so as C-band spectrum comes out, and they all have millimeter wave spectrum. Millimeter wave spectrum is where you're going to really get a multiple gigabit per second experience out of that device. And so that evolution is going to be, just like we talked about outdoors, more and more dense antenna networks, needing more and more bandwidth going to each individual antenna network, perhaps down to a point where every antenna itself is a sector, not like, where you have one sector covering an entire stadium and then 200 sectors covering, 10 or 12 antennas each. It could be down to one. And that's exactly where millimeter wave is. And so if you put a millimeter wave small cell in these stadiums, which we've designed hundreds of millimeter wave projects already, for our technology. I'll talk more about that later. But to get it into these high traffic venues, because this is where it's going to make the difference on people's experiences, but also open up all the applications that you can do because of that massive connectivity and that ultra low latency and the high bandwidth. So whether it's virtual reality or augmented reality or just smart buildings, but you'll see that evolution happen in these public spaces of deploying the infrastructure today for what you need to do today, doing it the right way. And I'll do a plug for Corning here. That right way is using a lot of fiber all the way up to the antenna point. It's not doing fiber out to a spot and going to 40 antennas via a coaxial cable to an antenna.
Mm-hmm.
That will not do what you need it to do. These are massive MIMO type networks. Millimeter wave alone has an 8x8, so a 64 element antenna array that is needed at each transmit point. That needs a fiber going to it. That needs a copper cable going to it for power. And so build that infrastructure right. And we're doing that now today. We've got a huge project that we're doing for the carrier consortium. It's a major airport in Southern California, and it is fiber to the antenna. They're taking a composite cable out to that antenna point, preparing for high capacity at 4G and 5G, and that ability to add on 5G in the future, because they're putting the right infrastructure in today to support this technology evolution.
Yeah, that's a great point. I know one of our clients is rolling out the same infrastructure, fiber to the edge, and the carriers, AT&T specifically, asked for additional fiber to each one of those REU on the Corning One system, more fiber to the edge, so that they could leverage that in the future. But it's
right.
Really around more data, right? And specifically, Murat, how will the demand for data and the infrastructure that provides connectivity impact our economy?
Excellent question. And Bill is 100% right in the fact that 4G is not going away. And all of the networks are 4G today, and they've started transformation into 5G. But it's going to take some time for all the applications to be fully adopted and built around this new network. However, 5G means economic growth today. And the reason it means economic growth today is the following. It is estimated that there will need to be approximately 300,000 new sites. We used to call them cell sites, whether they're towers or small cell sites, will need to be built in the United States. This estimate comes from CTIA, which is more than double of the number of vertical towers that were built in the last 30 years to be able to support 5G. That means that there will be construction crews, there will be permits processors, there will be engineering, civil and electrical engineering designers, radio frequency engineering designers that will start working on it today. In the state of Maryland alone, we expect the network build out to generate more than 9,700 jobs and $1.5 billion in GDP statewide.
Wow.
On top of that, the ecosystem, whether it's the equipment manufacturers, all the way from an antenna to cable to fiber to electrical power solutions to the base stations, are going to be providing and feeding into this growth or the infrastructure build out, while the service providers are going to start providing solutions for the end use case applications, which we're going to touch upon later on this panel, are being finalized. And last but not least, to stay competitive in the race, it is really important that, like some of the other states, Maryland also supports statewide infrastructure build-out rules. Based on the information that was provided to me, 30 states have already enacted legislation to streamline the infrastructure that provides the backbone for 5G. And I'm not just talking about towers. I'm talking about the electrical conduits and the fiber conduits that will need to be in place to be able to feed these sites.
Right.
However, this has not taken place in Maryland yet. So there is a little risk of falling behind as AT&T and their fellow service providers invest their capital in the 5G build out. But clearly, and again, LaTara will probably cover this, the state also can help this process by making her life and her colleagues' life easier.
Well, that touches, specifically on LaTara's expertise and her position with AT&T. We all see the marketing about 5G. It's all over the internet. It's all over our TVs. But what are some of those policy issues that we need to tackle, and how long is it all of this going to take to get it closer to current 4G coverage?
Yeah, I think it's important to also note, as Murat was sort of mentioning, that we have and I think there was a question in the chat, that we have an issue now with capacity, right, for 4G. We're strained on capacity. And then as we build out and get ready for 5G, there are certain things that need to happen. So a few years ago, the FCC did adopt some rules that would streamline the process for deploying small cells across the country. That was an important step. We needed to get that done. And the FCC, the US knew that this technology was important for the advanced technologies to sit on top of. You saw other countries, moving forward. The US only, as Murat has said, is actually, I believe it's like 31 states now that have adopted statewide legislation. Maryland opted not to. So we have been working jurisdiction by jurisdiction. I see a few of our partners on here from Baltimore County as well as Prince George's County. Both of your jurisdictions have adopted legislation. And we're still moving forward on some of the others, but it is a county by county situation. And you can imagine, thankfully in Maryland, we have 24, but even then it still poses concerns because one county is doing it one way and another is doing it the other. But we're going to work with our state. My home county of Prince George's County. Our industry and our supporters from many other industries also made an attempt at that statewide law that would build on the FCC decision and help further streamline the process. So like others in our industry, we are working with the local leaders to ensure that their policies are in place for small cell deployment and for the ongoing need for macro sites to deliver the services that Maryland wants. We fully support the goal of bringing broadband connectivity to every American and efforts to appropriate federal monies to connect areas where it has proven economically unfeasible to support broadband investment without some form of federal funding. We also support appropriating federal monies for permanent broadband benefit to ensure low-income persons and families can access the internet. So in short, we have some work to do. We do need to change the legislation, and we are working county by county in doing so. But those are some of the, Michael, some of the policy issues, because then you get into right-of-way agreements and so forth.
Right.
But I'll stop there.
Right. Well, it's a huge undertaking. I know, working with all the carriers and, specifically companies like Crown Castle that are building out this infrastructure. One of the questions was kind of focused in the chat about, are we deploying 5G because of an explicit consumer demand, or do we think build it and people will invent cool ways to use it? I know my personal experience, I utilize, my cellular phone for work every single day. And often, being a road warrior, I'm traveling and I need that data connectivity, even for calls like this. But there's so many more advancements out there. People are wondering, what do these things look like? Are they, conspicuous like cell towers? We watched them put up towers that look like pine trees, and, are these even less conspicuous? I know small cell, kind of lends its name to be a smaller form factor, but what exactly do these things look like?
Yeah, so we've, Murat, you can go ahead. I just want to say, just in the hearing rooms, we've seen all across the board. As the technology moves, we get more and more condensed in the actual appearance, but it's definitely not some of what you've seen. So Murat, I'm going to let you take that one as the engineer to kind of talk about exactly what they look like.
Yeah, so I saw the two questions, and first I'll try to answer the are we deploying 5G so that it's the build it and people will figure out new ways to use it. Definitely people will figure out newer ways to use it, but it's not a matter of building it such that it's there as a luxury item. It's a necessity now. All the new spectrum that, for example, Bill mentioned earlier, millimeter wave, C-band, you must have recently heard, are going to be new spectrum assets that the owners of this new spectrum are going to have to build infrastructure for. And they're going to use the most recent technology, which is 5G. So by definition, the expansion of the networks and the capacity expansion of the network is going to bring 5G in. But at the same time, according to estimates, by the end of 2022, the average consumer data consumption in the United States will be 22 gigabytes per month. This is probably a number that we would have made fun of a few years ago, or those of us who haven't had kids become teenagers to use their phones yet. But I think every single one of us who have that experience know that that might be an underestimation now, the 22 gigabytes. As LaTara pointed out, these kids do not use a TV. I have pictures of our family where a big screen TV is not turned on and they're all in their little iPads or iPhones looking at video. And again, that's a minor use case, but at the same time, we do need this capacity. It's almost like a utility. It's almost like a city making an investment into safer neighborhoods by adding traffic lights, right, or repaving the roads before winter so that the roads are in tip-top condition when it's, especially in the colder and eastern states, when it snows and when the salt comes in, that they can withstand the damage. So it's not a luxury, it's a necessity.
Yeah, I see 5G really unlocking innovation across all sectors, whether it's public safety, public works, smart communities, transportation, healthcare, and specifically education. As we've been at home, for quite some time, a lot of students still not back in school. But what types of other innovations are being built on 5G that we might see in our community soon, Murat?
I'll answer that. I'll quickly answer the other question, which is really important too.
Okay.
There was a question about how big these small towers are, and the person who asked had not seen any. That means that mission has been accomplished because they are around you. And the reason you haven't seen them is because they're not towers. They're actually existing assets. Most of them are electrical light poles, and you probably have not noticed it because we never look up per se. Nobody does, unless you see an owl nested there and your dog starts barking. There is an electrical light pole, and you next time you walk by, look at it to see if there is like a little antenna on it and a little radio. You might not be able to tell that it's a radio, but some other attachments there, and if there is more than one, usually they are what we call quote unquote concealed with material that covers them. So nothing to be scared of. They are inconspicuously deployed, and they do fit the environment. And LaTara again and her colleagues doing a great job in making sure that that takes place. But coming back to your question about communities, yes, there are, especially the pandemic has increased the implementation of certain of these use cases. One of them is education, remote learning. And interestingly enough, 5G, which is the enhancement of technology, is being used to close the gap in the digital divide. And let me explain it. Most of these initial deployments of these remote learning opportunities came up actually in rural areas where the build out of the traditional network is not necessarily there because there is not necessarily a return on the investment. At the end of the day, the ecosystem providers need to survive, need to be able to be profitable to be able to serve their consumers. However, these rural areas also had children and families living in them, and most of them maybe not necessarily at the level of wealth that they can afford other means of connectivity, where the either the local municipality or the school district, utilizing government funding, decided to step up. And when they decided to step up, they leveraged a new phenomenon called shared spectrum. For some of you who might have heard, at 3.5 gigahertz before the C-band, right next to the C-band spectrum that was auctioned, there is another spectrum called CBRS, which gives access to organizations like enterprises and or school districts or municipalities to build an independent private network. And then they built these in certain instances to be able to exclusively serve their student population so that they had access or they have access to online education while they're home.
Mm-hmm. Yeah, and I mean, this is a huge undertaking, and I know it's been going on for some time. But Bill, how is Corning keeping up with the demand for the actual fiber optics that's connecting all of this 5G in our deployments? You know, and what challenges do you see for the future of connectivity?
Good question, and yeah, it's difficult, but it's a good problem to have. Interestingly, this has gone, this goes back, and carriers like AT&T have been planning for 5G for several years now. So probably 3-4 years ago is when we started seeing the demand, and the way we prepared for it is by significant investment in new manufacturing plants for fiber optics, for cable, for the hardware to terminate this, by working closely with our customers to help design and plan out the networks. And so it comes back to the good old planning and investing. But what I'll also say is that, you think about this in the past, and still today in a lot of systems, people deploy and design and deploy one closed system. So they design up, the power source, the cabling pathways, the nodes where they put them, and they build a single purpose infrastructure for wireless. And AT&T might build another infrastructure for their AT&T fiber, the gigabit fiber to the home. And folks like Crown Castle for years have been creating shared infrastructure, I'll call them super highways, to go out to a shared tower with shared fiber going out there. And we think that convergence has to go further. You have to get more out of the digging that you do. You have to get more out of the cables that you lay. You have to get more out of the fibers that you put down. So that my analogy to that is like the interstate highway system and our paved roads. You know, we shouldn't have every application have to go build out their own infrastructure. There should be a way that we're able to build an infrastructure, plan for multi-use, and that's both outdoors and indoors. So plan for fiber to the home, plan for fiber to the business, plan for fiber to the wireless nodes, plan to wireless to every lamppost, or fiber to every lamppost, and plan for that. And also know that in this 5G world that not every place you are going to need to put a tower is going to be a light post. It might be something that doesn't have power going to it. So you need to plan for an infrastructure that has the right architecture, the right topology, the right pathway from data center to kind of an aggregation hub out to these points, and then the ability to get wirelessly or wired to anywhere else. But think about all these applications and all the users. If you do that, you build one 8-lane highway and the roads off of it, and you'll get much more for your capital dollar. You know, there'll be much more application, much more use out there, more money to spend on content and people inventing, you know, the new tools, the new iPhones or the new whatever that, you know, that will drive that demand. So we've done both things. We've ramped up our production, and we've tried to drive solutions towards this convergence idea, both indoors and out, so that you can, and like on indoors, for example, there's no reason why, you know, an in-building network you should drive. You know, right now fiber is 80 or 90% of the riser inside of a building, and then people pull category cable from a closet out 100 meters to all their different endpoints. If you took that fiber and some copper pairs for power out to zones on the floor, and then just jumpered with a short side road to keep the road analogy going, but to a short side road to your Wi-Fi access point, to your security camera, to your small cell, to your building sensors, and that's all a 10-foot or 15-foot jumper, you can eliminate 95% of the copper cable length inside your building, collapse many things down to a much fewer number of composite cables, deliver power out to the edge. And then when you need to add technology to your building or to your city, you've got someplace to go very close by to get power and data and bandwidth. And so that's part of our story. Corning's been pushing this idea for a long time, and many people are developing and deploying networks with this philosophy now, because it saves a lot of money, and it really future readies the infrastructure, the highways, so that we don't care if if it's an 18-wheeler or a, in what cargo it's carrying, and or if it's mixing my metaphors there.
Yeah, that's a great point. And I kind of relate that congestion to traffic congestion. And if we have larger highways, like we have larger fiber infrastructure, it makes it easier to get that data to all the places. LaTara, we've seen AT&T at Vision. We've seen AT&T start to deploy 5G upgrades for some of Vision's in-building DAS customers, specifically in the 850 megahertz bands. What have companies and communities been doing to prepare for 5G?
Yeah, so let me just give this data point again to kind of place it in perspective. Even prior to this past year, more and more Marylanders and Americans were using wireless devices more every day. We know that, right? Consider this: mobile data traffic on our network, on AT&T's network, increased more than 661,000% since 2007. That's just us alone. So we're talking about traffic and lanes, and when we know that type of congestion is coming, we plan, and that's the type of work that we're doing. So in terms of what companies are doing, we're creating connection with each other, with what people and businesses need to thrive every day. We do this by investing in our network to deliver these connections to our customers and to their need and what they've come to expect. From 2017 to 2019, we invested nearly $525 million in Maryland's wireless and wired networks. These investments boost reliability, coverage, speed, and overall performance for residents and their businesses. Nationwide, between 2016 and 2020, AT&T's total investment in the United States, including a capital investment in acquisitions of spectrum and wireless operations, was more than $105 billion.
Wow.
In fact, over the past 5 years, AT&T has invested more in the United States than any other public company. So we're here making the investment, knowing that things are increasing. COVID even took it to a totally different level, which we'll talk about a little bit later, but we're making the investment so that we can help our companies to thrive.
That's great. And, that brings up a point, Murat, specifically that, she talks about investments, moving to 5G requires a large investment in communication networks. That can include cell towers, in-building aids, rooftop antennas, small cells. To have the most complete coverage and capacity in all environments, we need a combination of all those elements. So how are other companies, such as AT&T, Crown Castle, preparing for this large of a build? Because it's ongoing.
We are working together because this is not something that anybody can do by themselves. I think we've heard it from Bill, where he underlined the fact that as more of the investment into sharing common goals, common interests get aligned, then the innovation accelerates. Because number one, it will free up capital, at least theoretically. And then number two, it's going to increase the speed at these assets are being made available. It will provide some uniformity and hopefully allow states like Maryland also join the other 31 states, as LaTara mentioned, to approve and easy to act upon rules for the infrastructure to be built. Because again, as the applications are being developed, as the solutions from either electronic vendors or glass innovators like Cune are coming into play, as players like Crown Castle are investing, and as service providers like AT&T are spending incredible amounts of money. And again, even without the figures that LaTara gave, if you looked at the C-band results, you can see how much money the service providers are spending. It has to be all coming together to make sure that we have a reliable, safe, advanced network that will not only serve its consumers, but increase or make our lives better with enhancements in the smart cities, healthcare, education, and all other new applications that are knocking on our door right now.
Right. Well, I mean, that's a lot of advancement. And you talked earlier a little bit about shared spectrum. Tell me a bit more about how communities and businesses are using shared spectrum to advance the innovation for emerging technologies.
Yeah, community-wise, I gave an example of the remote learning for the rural school districts. We've seen an implementation in the city of Tucson, where the city itself decided to invest in building out a private network to not only help their school districts, but also enhance smart city type applications where they can do sensor-based parking meters or parking guidance. I believe I've seen a note where in the city of San Francisco alone, the smart parking generated multiple millions of dollars of additional revenues, while decreasing the time it takes, I'm looking at the notes, about to find a parking space by 44%, and a 30% reduction in miles traveled and greenhouse gas emissions.
Wow.
Imagine this happening everywhere in every city in the United States. It adds up, right? And this is, again, part of the everyday benefits that we will all enjoy. Yeah. With respect to private businesses, they can leverage this 5G and using these shared spectrum capabilities, either by requesting tailored services from the service providers, or they can try to build and manage it themselves for higher level security applications that might or might not have been possible with other wireless technologies like Wi-Fi or Bluetooth or Zigbee.
Right, right. That's a great point. So we heard from AT&T and Crown on what they're doing in their investments. Bill, specifically, Corning produces a massive percentage of the fiber infrastructure we've been talking about that's really driving 5G into these communities and into our cities. What else is Corning doing with 5G and emergency technologies? I've seen, the Corning One platform for a couple of years and the 5G roadmap from Corning. But what's there now? We have a question about, we've talked about lampposts, we've talked about towers, but what are we doing to get this inside? If a lot of this communication is happening indoors, what are we doing to extend that? And maybe touch on the differences in 5G, low band, medium band, and high band, and how millimeter wave is faster possibly. But what's Corning doing to kind of break down those barriers and extend this more indoors?
Sure. No, glad you asked the question. So, because I have been talking a lot about the fiber and the cable, which is, of course, important. But Corning in 2010, prior to 2010, Corning was doing a lot of research and development on the active electronics to enable this thing that they saw coming. And 2010, we really stepped up and got into the wireless actives business. And so we do have distributed antenna systems, both indoors and out. We have a small cell business, 4G small cell. We now are a leader in deploying 5G millimeter wave small cells. We have investment in virtual RAN and open RAN activity going on as well. So we have this roadmap of indoor products that not only advance this cause of cellular inside the building, whether it's low band, mid band, or high band, or millimeter wave. And the interesting thing there, the difference is many of them lend themselves to a distributed antenna system where you're just putting RF out throughout the building. Others lend themselves better to being an access point at the edge, like a Wi-Fi access point that needs to do certain things that just make it necessary to be that access point out at the edge. And so a full cell site out there. Private network CBRS, we implement that with a small cell network because of and that needs a backhaul. So you've got front haul, you've got backhaul, you've got these mid-haul type technologies. And so what we've done is we've built not only the fiber and power out to the edge and the powering solutions to deliver power. We delivered all of that, or developed all of that, and then these devices at the edge to enable all of these networks. So from DAS to small cell to millimeter wave small cell to open RAN, but all built on that common shared premise of if you build a 12 fiber, 12 conductor infrastructure out to a zone in your building every 2,000 square feet, you'll be able to connect anything to it at any point. And so as these technologies evolve and as new things come along, that's what that's how you'll be able to adapt and add new technologies. And so we do have all of that technology, as you know, and on our roadmap is to continue to invest in these technologies to be able to add elegantly new frequency bands as they come out. C-band is a couple hundred megahertz eventually of spectrum that will probably be deployed 4x4 MIMO. So just for C-band, that's 800 megahertz of spectrum you've got to get out to an antenna point.
Right.
That's a big deal, and it's going to have to be done in a little different way than the DAS systems that we're deploying, say, a few years ago, and even ones today that are going in with hybrid fiber coaxial cable networks. They're not going to deliver the kind of performance that is needed without having that active element out at the edge. And so Corning's at the forefront of pushing that architecture and that technology. And we also have to add on to it, because I mentioned Wi-Fi and cameras. We do have our own software-defined LAN technology. So it's we can do PON, we can do active Ethernet. We have small, few port to 8 port switches that go out at the edge, very low cost, but that take advantage of that fiber to the edge infrastructure to enable whatever you need to put in your buildings. We've also developed an intelligent powering solution that isn't just to power these devices, but could also be used to power a sound masking system or power your shade controllers, all from that edge zone. And so the point there being, let's get away from all of these building systems that are all putting something in an MDF and something in a floor closet and then running their own cables 100 meters out to the edge. Let's try to get that highway built out there that is power and bandwidth, very close to the edge, and think beyond just what we typically do. So Corning's doing research and partnering with companies to have all these systems use our power supply and power source, and to have all these use our infrastructure to enable their connectivity and their power. And so that's the exciting thing for us. It's taking that convergence to the nth degree, and and leveraging that for savings for the building. Every time you don't have to run a project and pull a cable 100 meters, you've got money left to spend on an application or on some technology.
Yeah, and that brings up a great point, because Vision has hundreds of technicians and engineers out in the field, and we have been for the last year through COVID. So we've used these networks extensively throughout this for our data meetings, for our communications and keeping in touch. Some more advanced analytics that we can do in the field. But there's a larger portion of the population that's been affected, in the last year. So LaTara, how has the last year demonstrated the importance of strong mobile networks and the need for that?
Absolutely. So this is where the rubber hit. I think with the pandemic, unprecedented altogether. Right around this time last year, as hundreds of millions of people were quickly transitioning from their normal lives to staying home, there was a widespread and rapid transformation of how Americans use their devices and their networks. According to our industry association leader, I have some really fascinating statistics I just want to read with you. The voice traffic and texting, rose significantly. Voice traffic increased from 20 to 40% on wireless networks. This growth is all the more significant. Nearly 80% of voice connections in the US are wireless. Major wireless providers also saw a 25% increase in texting, okay? Mobile hotspots, everyone remembers that. They soared. You were lucky to find toilet paper before you could find mobile hotspots back when the pandemic started. They were very difficult to find. It's important to note that COVID-19 traffic increase is on top, it is actually on top of the regular rising mobile data traffic trends that Bill and Murat and I and Michael and I have all already been talking about. For instance, the increase in mobile data traffic in 2019 from 2018 alone was greater than the entirety of mobile data traffic just 4 years ago. Application use skyrocketed as well. Thinking about how we were using our healthcare applications. If anyone is on this call that's in healthcare, you are our heroes. We thank you so much. But imagining, what had to happen as those true rock star warrior heroes of ours were doing their work. The Cleveland Clinic, for example, saw monthly telehealth visits jump from 3,400 to over 60,000, which is an increase of 1,700%. And then finally, traffic volume for Cisco's WebEx, where we happen to be on Zoom today, but that spiked as well 25 times. So through it all, our networks did hold up. But again, we know that we are headed for, an area where we're not going to be able to sustain, especially now that the advanced technologies are coming along. So I just want to make sure that everyone on this call knows that we need to work together in Maryland to get this work done. We need to continue to pass the legislation in the jurisdictions that will open the pathway, open the doorway for us to build.
Yeah, and I've seen, my internet at my home go down more often than not since the pandemic started. And I think that that's a tax on that particular infrastructure, whereas I'm able to turn on my mobile hotspot, get online, and it's actually faster than my home network, which is amazing. So, and LaTara, expand a little bit more about, how broadband and mobile broadband 5G is going to help deal with things like the homework gap or digital divide that we see in our country today.
Yeah, I think Murat really kind of touched on the way, we're focusing a lot of our energies on the homework gap, helping our young people to get access to the technologies and so forth. But children are learning and operating and processing at a very different level than even we did, right? My kids, I'm amazed at how they can handle listening on the phone, texting, doing. I'm like, how do you do that? They just process very differently. So we now had to sit down, the whole country did, and we had to really evaluate and see the gaps that just we struggle with. We in Maryland had an article that came out just a few days ago regarding the number of children that were failing in our school systems, right? So we can't turn away from that anymore. It is, and I'm case example. I have four children. I have three that did extremely well in the pandemic and one that really struggled, right? And so we had to figure out what we could do to help him to better learn and deal and cope and move forward. So I think that this has brought a spotlight to so much in this country and specifically in Maryland, and how we need to move forward with building out of the infrastructure.
Yeah, that's a great point. We had a question come in about business to business space and how 5G is going to help business to business. A lot of the things, we haven't even touched on, other than mentioning, autonomous vehicles and, faster internet, those data transformations. A lot of the devices that the Vision installs are wireless at the edge, and 5G is really going to enhance how businesses do business on a day-to-day basis. So I want to go around the horn for one of our final questions as we wrap up with about 5 minutes left. And I'll start with you, Murat, with where are we with emerging technologies and 5G, and maybe describe the impact that 5G will have on emerging technologies and how that's going to further impact our communities. And then from you, we'll hand it off to Bill, and then we'll let LaTara wrap it up.
Right. And I think we all touched upon it in earlier in the session, but as I mentioned, the emerging technologies that we will see different from 5G, because with respect to us mobile users that are using our handsets or phones, we just take the increased speed as a granted right, just like, again, like a teenager. We think it's our right. And probably as a users won't feel it as much. Because I remember first time I watched a broadcast of a sporting event on a high definition TV, I'm like, oh my goodness, I can see and hear their shoes, and I can see the little pieces of the floor that they're stepping on. Now it's like somebody asked, like, when you see older footage, like, how did you watch that? I'm like, we didn't know what we didn't know, right, at the time. So that's not going to change. But the biggest impact, as we mentioned before, is going to come in smart communities for our everyday use, for the benefits that we enjoy being members of the communities that we live in. Education, with all the things that we've talked about, whether it's remote learning or when we're learning in the classroom. One of the features that will be available with the ultra low latency, high speed 5G network will be virtual and augmented reality. You can't do that without that intense bandwidth and the high computing capacity that's available to process those bits that are going around us, right, and ending up in the devices. Healthcare, as someone mentioned before, just the fact that, as LaTara said, those telehealth visitations went up. Guess what? The cost of those visits went down. So ultimately, it makes the health system better. And also frees up important resources for the cases which needs more attention than another case which might not be as urgent, that now we might be able to identify.
That's great. So Bill, real quick, if you can touch on, just, in 30 seconds, the security of 5G. We're talking about putting a lot of data on there. It's secure? I mean, it's a lot of data.
Well, yeah, absolutely, it's secure. I mean, cellular systems are inherently secure over the air, and then, and quite frankly, you put this on fiber optics. It's pretty hard to tap fiber optics without being a professional. So these networks are secure. I mean, they're certainly better than, and I love Wi-Fi. We all love Wi-Fi, and we need to use Wi-Fi a lot, and it helps offload things from these cellular networks. But yeah, it is a inherently secure technology, as long as we get it from the right sources and deployed by the right operators like AT&T.
Great, thanks. So LaTara, I mean, this is going to be a benefit for all of our communities. So if you want to close it, I appreciate everybody's participation. If you could just close it on the dramatic impact this is going to have on our communities.
Absolutely. And one, for us, Michael, we all want to thank the Tech Council for bringing this group together to have this important discussion. Certainly, I think we have demonstrated and shared with the audience today just the importance of us moving in the direction so that we can be at a space in which we can receive these technologies. We have, people can predict where we are now and where we are going with this and how it will enhance our systems, enhance our businesses, enhance the way that we do work is just remains to be seen. As I mentioned, in terms of education, I'm looking forward to it. I know that I have a son that is struggling, but you know what? His teacher is teaching different now.
Right.
He's responding different now. So the technology, the way that it will help our systems is something that will be beneficial to us all. So to close out, again, thanks for everyone that joined the call, for the state, the elected leaders that are watching this. Let's get the work done. Let's move forward with advancing any legislation, clearing any roadblocks, any hurdles that we might have that helps us to bring this technology here to Maryland. So thank you.
That's great. Thank you, LaTara. I appreciate your comments. Murat and Bill, thank you as well. And especially, as LaTara said, thank you to the Maryland Tech Council for bringing this important issue up. Have a great day.